Hello everyone. Today I will take question number 21 to 25 in NEET 2016 series CRY. So question number 21 to 25. Question number 21. Coefficient of linear expansion. Linear expansion of brass and steel. Of brass and steel rods are alpha 1 and alpha 2. Lengths of brass and steel rods are L1 and L2. Are L1 and L2 respectively. If L1 minus L2 is maintained same, L1 minus L2 is maintained same at all temperatures. At all temperatures. Which one of the following relation holds good? Holds good. Now the option. First is alpha 1 L1 equal to alpha 2 L2. Second is alpha 1 L2 equal to alpha 2 L1. And third is alpha 1 L1 square equal to alpha 2 L2 square. And now fourth, alpha 1 square L2 equal to alpha 2 square L1. These are the options. Now the solution. Now in this question you are given the two rods, one of brass and second of steel. Their coefficient of linear expansion are given alpha 1 and alpha 2. Their initial lengths are L1 and L2. So it is given that if L1 minus L2 is maintained same at all temperatures, which of the following relation holds good? So we know that increase in length. Increase in length. Delta L equal to L1 and this alpha 1 and your temperature T. T equal to temperature. And this is your delta L. This is for brass. For brass. And delta L equal to L2 into alpha 2 into T. This is for steel rod. This is suppose L dash, this is now suppose delta L dash. So now this is given that L1 minus L2 is maintained constant. The difference of two rods is the same. Then what will happen? That in this case, actually this question is not clear. L1 is the length of brass rod and L2 the length of steel rod. When both are given the same temperature, then there will be a change in length. But in case of this L1 minus L2, this is not the same in both the cases. So what should have? This question must be that if the increase in length in both the rods is equal, then which of the relation holds good? This must be the language of the question. So I think that this language given in the question is very ambiguous or very doubtful. Since delta L equal to delta Ls. So this is your L1, alpha 1 T equal to L2, alpha 2 T, this T and T will cancel. So L1, alpha 1 equal to L2, alpha 2. So our right option is the first. Answer is first. So this is given in the question, but if we solve to according to this one, you cannot get this answer. While answer this is correct one. This is correct one. Here the language must be that if the increase in length of both the rods is constant at all temperatures, then which of the following relation holds good? Then this must be given here. So this is doubtful, and actually what happens that when such questions are given, then they become the challenging questions, and many students are challenged this in the court, and because of that there is the delay of the result and students suffer from it. So remember that this is not the accurate language of the question. So what should be the correction? That I have told you here. And now question number 22. A astronomical telescope has objective and eyepiece. And eyepiece. of focal lengths of focal lengths 40 and 40 centimeter and 4 centimeter respectively. To view an object, view an object 200 centimeter away, 200 centimeter away from objective, the lenses must be separated. Must be separated by a distance Options are: first is 54.0 centimeter, second is 37.3 centimeter, third option is 46.0 centimeter, and fourth is 50.0 centimeter. Now solution to this question. Now here you are given the objective length of focal length 40 centimeter and eyepiece of focal length of 4 centimeter. We have to view an object which is 200 centimeter away from the objective, and then we have to find that what should be the distance between the objective and the eyepiece. So this is the eyepiece, this is objective lens L0, and this is the eyepiece here. This is the object here, this is object, and as here is the image that is formed here. So what we have given, that we are given the focal length of this one. This is now focus f0. Then what we have, that this we are given the distance of 200 centimeter, and this is now V, and this is formed at the focus of this objective lens. So this is also the FE. So this distance is given 4 centimeter. This image formed here at the focus of this eyepiece. So the final image will be formed at the infinity. So what will happen, that this image if I draw it long, then this will pass through this one, and another ray will pass through this, and when we increase them, the final image will be at infinity. So now distance between these two lenses, distance between lenses equal to V plus 4. So we have to find the V. You are given F naught equal to 40 centimeter and this U is equal to 200 centimeter. You have to find the V. So apply the formula 1 upon V and this minus 1 upon U equal to 1 upon F naught. And here this 1 upon V minus 1 upon 200 with a minus sign is equal to 1 upon 40 and then calculate. So this 1 upon V is equal to 1 upon 40 minus 1 upon 200. So now we take LCM 200. So this is now your 5 minus 1. So 1 upon V equal to 4 upon. Now this will cancel 50. So from here V equal to 50 centimeter. Therefore, distance between lenses equal to 50 plus 4 equal to 54 centimeter. So this you are given the first choice. So our answer is first. So what you have to find, this is the application of this astronomical telescope. You are given the distance of the object from the objective lens and then you find that where the image will be formed. So remember that image is to be formed at, final image to be formed at the infinity. This is only possible when this image is at the focus of this point, of this lens. Eyepiece. So the finding to this one, then you just add to this V with the focal length of this lens. So this is now 54 centimeter. Or this we rather to say FA. Now question number 23. A uniform circular disc of radius 50 centimeter at rest is free to turn about an axis which is perpendicular to its plane, and passes through its center. It is subjected to a torque. It is subjected to a torque which produces a constant angular acceleration of 2.0 radian per second square. Its net acceleration in meter per second square at the end of 2 seconds. At the end of 2 seconds is approximately Now options. First option 3.0, second option 8.0, third option 7.0, and fourth option is 6.0. So these are given the options. Now the solution to this question. This is given that a uniform disk rotates about its own geometrical axis, and when a torque is applied on it, it produces an angular acceleration of 2 radian per second square. The radius is also given here. Radius r equal to 50 centimeter, so this is 0.5 meter, and you are given the turnabout through object, and this is given to alpha equal to 2.0 radian per second square. This is free to rotate about an axis. This means that the initial angular acceleration, angular velocity, this is equal to 0. So now we know that when the object moves in the circular orbit, then it has two kinds of accelerations. One is centripetal acceleration, and second your tangential acceleration. So centripetal acceleration AC, this is equal to V square upon R, or this is equal to omega square upon R. And tangential acceleration, AT, this is equal to R into alpha. So now we are not given this V, we are not given this your R is this alpha is also given, so we can find this AT. Therefore AT, R equal to 0.5, and this is now your 2, so this is 1.0. meter per second square. Now to find this equation, this centripetal acceleration, we are given this omega square into r. So this alpha is given to you. So omega. Now note that t is given here. At the end of 2 seconds, this is given that time t equal to 2 seconds. So omega equal to omega naught plus alpha t. We use the equation of motion. So this is your 0, alpha is your 2, this is now 2, so this is now 4. We are getting this 4 radian per second square. Therefore, centripetal acceleration AC equal to omega square r. Omega is now 4 square, r is your 0.5, so this will come out to be 8 meter per second square. Now then you have to find the net acceleration. So net acceleration, A equal to square root of AC whole square plus AT whole square. As I told you earlier that these two are mutually perpendicular to each other. So this AC is given to be square root of 8 square plus 1 ka square. So 1 is very small in comparison to 8. So when we this 64, this is now 1. So we can neglect to this 1. So approximately this A will be equal to 1. Approximately 8 meter per second. This is the net acceleration. So now our right option is to second. Second. 8. So what we are given, that whenever we are asking the net acceleration in case of circular motion, that always remember that we have to find the centripetal acceleration and the tangential acceleration, and then find the net acceleration by squaring and adding the 2 and then finding the square root. So this will give you the net acceleration. This is the question number 23. Now question number 24. A refrigerator works between between 4 degrees Celsius and 30 degrees Celsius. It is required to remove to remove 600 calorie of heat. 600 calorie of heat every second in order every second in order to keep temperature of the refrigerated space of the refrigerated space. This is the question of refrigeration. Refrigerator space constant the power is now the options, and this is given, take 1 calorie equal to 4.2 joule. So now options are, first is 2365 watt, and second 2.365 watt, and now third 23.65 watt, and number 4 236.5 watt. This is given to you. So now solution to this question. Now we are given the refrigerator, and in case of refrigerator we have the coefficient of performance. Coefficient of performance beta equal to T2 upon T1 minus T2. So here this T1 is given to be 273 plus 30. So this is your 3, and this is 10, so this is now 3. So much K. And T2 is 273 plus, this is now 4 degree. So 277 K. And beta, you know to this one, that this is now your Q2 upon W equal to T2 upon T1 minus T2. You have to find the W, or W equal to Q2 into T1 minus T2 upon T2. This is so much. Now this Q2, it removes the heat. How much? This is now 600 calorie. This is given to here. This is 600 calorie. This is 600 into 4.2. This is so much joule. So now put these values, 600 into 4.2, and this is your 303 minus 277 upon 277. So you will get it to your, this is now your 2, 24 and 25, and this is now 2 0, so 0 is here, and just you have this, this is now your 6, and this is 9, so this is now 2, 26 upon 277. So if you just calculate, then you will find it to be 236. This comes out to be 236.5. So much watt. So our answer is, your answer is 236. This is now 4th. So this is the direct application of the coefficient of performance of the refrigerator. You are given the T1, T2, and you are given the Q2. Then you have to find the work that is to be required. So that will give you the power, because this is given the heat per second. So what we are getting this W, this is now joule per second. Joule per second, this is now watt. This is question number 24. Now question number 25. A gas is compressed isothermally to half its initial volume. The same gas is compressed separately through an adiabatic process until its volume is again reduces reduced to half. Then the options. The first option is which of the case whether compression through compression through isothermal or through adiabatic process. Isothermal or through adiabatic. Process requires more work will depend upon the atomicity of the gas. Now second option, compressing the gas isothermally. The gas isothermally will require more work to be done. And now third option is compressing the gas through adiabatic. The gas through adiabatic will require same amount of work and fourth option, compressing gas isothermally or adiabatically. Will require same amount of work. Now here we are having this now solution to this one. This is now your pressure, this is now volume. When they are compressed, this is suppose initial volume and to the same amount of then this is your adiabatic and this is isothermal. You take this in of complete volume. If we take the half of this volume, this is so much, and here we are giving the half of this too. So you see that this curve has the less area in comparison to this, the curve which is given above to this one. So work is more for adiabatic in comparison to. So this we do like this. So W adiabatic is more than W isothermal, because this area for isothermal is less than the area for adiabatic. So here we have this W adiabatic is more than W isothermal. So we have the correct option to this one is more. Compressing the gas through adiabatic will require more amount of work. So our right option is, answer is your third. So I think the some of the options in this question are not accurate. While if you read the first option, it is not telling us that this is already a question. Which of the case requires more? So which of the case requires more? So this is also a question. While this option should not be in the form of a question. This is wrong one. Compressing the gas isothermally will require more work. Compressing the gas through adiabatic will require more work. Compressing the gas isothermally and adiabatically will require the same amount of work. So these three options are in right language, but the first option is in the wrong language. So we have that the work done in compression of the gas to the same amount of the volume, the work done in adiabatic is more than the work done in isothermal process. While in case of expansion, the work done in isothermal is more than the work done in the adiabatic process. Thank you.